Example 5 puts everything together. It culminates the whole lesson. So here we will be dealing with permutation and dealing with combination. And also with this, I'm going to show you how to put things into the calculator. So with this again, go ahead and write down the question. Now here with this question, there's an A, B, C, or A, B, and a C. And so here, just make sure that you guys get the C also. So here's A and B. If you want to stop the video now, go ahead and stop the video. And then you can move down. And then here's C. Example 5. At Grant Senior High School, there are 15 names on the ballot for junior class officers. 5 will be selected to form a class committee. So we're talking about the class officers, and then we're talking about a committee there. Well, the class officers are part of that committee. Sorry, my fault. So A asks, how many different committees can be formed? Now, when we talk about a committee, are we talking about specific order? This person's ranked here, this person's ranked here, this is president, vice president, secretary, or we're just talking about a group of people? We're talking about just a group of people there. So when it comes to A, we're not talking about permutation because order doesn't matter here. We're just talking about a group of people. So for A, all we're going to do is deal with our combination. Let's do this part here. Let's bring it down. Here we go. A. It's just a combination, a group of people. So just a group of people. So here, we have to remember or think about how many people are there in all. So there's 15 people in all. And how many are we trying to get in our committee? So we're only trying to get 5 inside our committee. So when we do our combination, we can do 15, 5. And remember, like on the when we do our information parts or the pretty much informations of combinations and permutations, we said we could rewrite these a different way. Because I'm getting ready to show you guys how to do this in the calculator. Yay! So we're going to do 15, the C, and then 5. And we're going to put that in the calculator just like that. But when we put in the calculator, we're going to actually have, instead of just a C, it's going to be NCR. So when you actually look at it in the calculator, you're going to see 15 NCR 5. But when you actually write it, you take off the NCR part, the N part, and the R part. So let's go ahead and do that really quickly. So we're going to put the number 15 in. Number 15. We hit the math button again. Math. Okay. We're going to go to the right, left. So we hit math and went to the left. And then we see number 3, which is NCR. So in other words, we went to the same place we had where the factorial button was. The factorial sign was, function. So we're going to go to NCR because we're talking about combination. Put that there. And then we're going to put number 5. So it should look exactly like that. So 15, the NCR part, and then 5. And when we write it again, it's 15C5. All right, so hit enter. And we get 3,000, 3 possible ways. Possible ways. To have a committee of 5. Okay, so that's A there. Not hard. That's simple. It's pretty easy. So it's 15 possible, 3,003 possible ways. All right, so that's A. So let's go to B. And again, B here says, and how many ways can a committee of 5 be formed if each student has a different responsibility? So a different responsibility. So like, for example, let's say president, vice president, secretary, and treasurer. And then sergeant at arms or something like that. So let's say we have that, those 5, And because they're all different responsibilities, the president has a different responsibility than the vice president, different responsibility than the secretary and the treasurer and sergeant at arms. They all have different responsibilities. So with that, does it matter the order that we put the people in, or is it just willy-nilly like group people? It matters the order because we're talking about specific responsibilities for each person. So here, that means permutation because we have different responsibilities. Different responsibilities. So if it was just, again, like a group like we did for A, then we just put combination and be done with it. But because we have different responsibilities going on here, we have to do permutation. So again, we have P. And in all, again, there's 15 people. And we're trying to make one with 5 people in it. And again, because it says a committee of 5, but it says that everybody has a different responsibility, so therefore it changes to permutation because order matters. So again, you can do 15P5. And in the calculator, again, that's going to say NPR. Like the radio station, NPR. You probably don't know about that, sorry. If you do it again, good. So we do 15, go to math again, go to the right, and go down to number 2 this time. Sorry, left, and then go to number 2. So we went to math, went to left, and then number 2, and then put 5. And see, there's more numbers here because it's permutation. Permutation always has more numbers than combination. Combination. See, like how I said that. All right, so there's 360,360 possible ways to have 5 committees, or have a committee, sorry, of 5, to have a committee of 5 with different responsibilities. Okay, so that's that. That's B. All right, and then C. If there are 8 girls and 7 boys on the ballot, so if you add them up together, that gives you 15, right? Okay. How many committees of 2 boys and 3 girls can you form? And again, that's 5 in all. 2 plus 3 is 5. There's 15 people in all. But this time we broke it apart, or they're breaking it apart. They're saying boys and versus girls. So when we do with this part, first off, does it matter what order that we're putting them in? Or they just say boys and girls? Does it matter like responsibilities or order or anything of that sort? Now, order doesn't matter. Again, so for C, order does not matter. So it's combination. So we're just talking about boys and girls. That's all we're talking about. Now with that, we're talking about combination. So we're going to have to deal with the boys by themselves and the girls by themselves. Let's start with the boys here, then the girls. So we have to find a combination of the boys, find a combination of the girls, and then go from there. All right, so for the boys, we know, again, combination. How many boys are there in all? 7 boys. And how many boys are we trying to get on the committee? So we need 2 of the boys out of the 7 to be on the committee. Okay, then for the girls, combination again. How many girls are there in all? There's 8 girls. And how many girls are we trying to get on the committee? 3. Okay, and with this, because we're talking about the combination of boys with the combination of girls, we're always going to multiply. Always. Always. All right, so when we do this, put this into the calculator, you get 21. So if you want to do that really quickly, you can do that. Put that in the calculator really quickly. And then here for girls, you get 56. And again, you can put that in the calculator really quickly. If you multiply those, we're going to get 1,176 possible ways. To have 2 boys and 3 girls on the committee. Now that one, that might show up a couple of times, different places. That's a more in-depth one where you have to put things together. So just prepare for stuff like that too, especially the letter C. All right, and that's the last example. Woo!